thank you for coming. For the ones that don't know me, I'm Hernâni. I've been working with Drupal for more than 15 years in different functions, but mostly as an architect. In the last years, I've been working in the European Commission as a Drupal consultant for several of their projects. I am from Portugal, from the other side of the border, and I like history. This talk actually is going to be a lot about history. And you have a picture there of me yesterday in front of the Santiago Cathedral. So today I want to talk about a strange topic, time, and the way that time affects our work and ourselves. And the talk is basically inspired by two things. First, the effect that time has on our work and the fact that we cannot create legacy work. Whatever we do typically lasts a few years and it's destroyed or rebuilt. We don't have anything to show as legacy to the next generations, to our children, to our grandchildren. We are not going to have pyramids to live as a legacy, but we can have products that last longer than what we do right now. And this talk is mostly about suggestions for what we can do so that our work lasts longer and is not killed a few years past. And it's also inspired by what time does to ourselves. That picture is a picture of myself in New York when I was 25. And I was starting my career. I was heading one of my first trips for work. And we went to New York to replace a CMS that was based in ISP.NET. And we were replacing it with Drupal. This was 16 years ago. And I remember that I have this guy on the team that he was trying to learn Drupal from his old mindset of ISP and struggling a lot, and they didn't like that transformation. And he told me, be aware, today you are the cool kid on the block, but soon you'll not be. That was a learning that I tried to keep for the majority of my career. And that's something that we need to have in mind all the time. Time passes by us, and we stop being the cool kids, and we start being something else. Right? The second picture is from a celebration that we had this year of the 24th birthday of Drupal, so that's a long time. I want to have the session a bit interactive as well. So I want you to think about what is the oldest technical project that you have still working today, that you have started working some years ago, and that is still running today in some shape or another, in some other technologies maybe. But think about how many years passed since you started. Think about why is it still running and it didn't die. Think about how many times did it change of technology, of versions, of people, of teams. Think about how many times it could have died. Like there were several occasions in the past that probably it could have died, but it's still running. And think how many people touched it. Okay? So raise your hand. How many years passed? +2? Everyone? More than 2? More than 5? More than 10? Starts to be very hard. More than 20? No one? See one. There you go. From the beginning, without many changes, but still with the same concept. More than 20. That's very impressive, and it's very rare these days. So how long does software typically last? So it depends on what type of software we are talking about, right? So if it's a simple landing page website, they used to last 6 to 12 months, but actually if you transform them to static HTML, so if you reduce the complexity that they have, they last forever. That's why we archive websites. When we finish DrupalCamps, first thing we do, we archive the Drupal site. That's going to make it last forever. If you are talking about consumer apps, mobile apps, they change very often. 2 to 3 years, they're dead. You need to rebuild them. You need to refresh them. Business corporate websites, 3 to 4 years, and they have been the age has been growing over the last decades. If you look to government websites, you have a larger time stamp, 4 to 6 years. If you look to commercial or enterprise software, things that you have to deploy inside the company and support, 5 to 10 years. If you think about the software that runs on an embedded system, like a car, you're probably talking about more than 20 years. So it really depends. But anyhow, if you compare to our other engineering colleagues, if you look to other engineering fields, if you look to electronic engineering, mechanical engineer, civil engineer, chemical engineer, what we do is just minutes. If you look to electronics, majority of phones and laptops last from 3 to 5 years. If you look to routers and switchers, 5 to 10 years. If you look to medical devices, 10 to 20 years in electronics. If you look to mechanical, cars, typically 10 to 20 years, the average is 12 years. If you look to civil engineering, buildings are made to last 50 to 150 years. If you look to bridges, they can last 200 years. If you look to chemical, patents, when you build a drug patent that lasts 20 years after usually a generic appears. But the medical use for some substance that you put on the market can last easily from 50 years to 100 years. So that's a lot of time. If you want to put that in perspective, on top you have things that last 150, 200 years, and then on the bottom, here we are, building software that just lasts 2 years, 4 years, almost nothing compared to the rest of the remaining engineering fields. You know what is ironic? Is that if you look to software, in theory, it could last indefinitely. There's no time decay, there's no erosion on software. There's no physical reason why software stops working. But in practice, it's the first one to die across all these other disciplines. Why does software die? Well, there's different reasons. I try to put some sort of categorization on them. Business, that's the most typical one, that software is not used anymore, which is strange. Typically, the software that did something is going to be needed in the future to be done in a different way. Technology, that's quite often. There is dependencies on your software that are not supported anymore. There's language versions that change too often. There's security vulnerabilities that are found on your dependencies, on your code, that makes it die. We rely a lot on external services. We think that whenever we depend on a big service like YouTube, Google Maps, they're going to be there forever. And that's not true. They die quite often. And whenever we have a dependency to them, we die with them. And also because there's no knowledge to adapt it. So if we became very niche technology and there's not enough engineers in the market to support it, then the technology is going to die. We die because of the expectations of users. Users want always new things. They want fresher looks. That's very common in our field and web. The majority of the websites die because they want a rebranding of the site. They want a new look to the site. But also because users want better UX to interact with the sites. Like they don't want anymore just a site that I can use on a computer like I wanted 20 years ago. Now the majority of the users actually interact with your website through a phone or through smaller devices, and now they start interacting through voice or through AI bots or different ways that you have as an interface to your site. So if you don't support those interfaces and you don't support those medias, then you are going to die. And it dies because software requires changes quite often. You need to adapt your software to your business. And sometimes, or very often, is easier and cheaper to change it by rebuilding it than it is to adapt it. And when that's the case, then software dies. Either because it's integrated in a larger, smaller scope project, you have something that can do also what you were doing, so it's integrated there, or there was a change of technology. ASP was very popular when I started. Drupal came, replaced it. Now a lot of things are replacing Drupal as well. Just change of technology, pretty much doing the same, but just in a different way. How does it survive? Well, it survives when, for the business, the software is still useful and does not present any risk for your business, so it's safe, and it can run on the current form. It survives when there is a large ecosystem. People have habits. People know how to use things. And when they are used to do something with your software, they are reluctant to do it in a different way. So if you have a large ecosystem, it's very harder to die. It survives when you do have a technology that is supported, updated, with security releases, and that is easier to refactor. And it survives whenever there is a need to do a change, you can do that change without cracking your software like a castle of cards, like everything destroyed because I touched that service that was dealing with user management, without costing more than a rebuild. So if it's cheaper and simpler to just do a new project with a new team and rebuild it, then people are going to choose it. And it survives when you are not the only software wizard that can change that software. If you are the only person that know how does that sync work on that subsystem of your software, then it's very likely that that's not an advantage for you. It's really something that will make your project in danger. So let's look to a few examples of software and projects that last. And let's see what do they have in common, or some properties that they have in common for that age length that they do have. So if you look to Linux, Linux born in 1991, that's 34 years ago, okay? That's a long time span. Why is it still here? And Linux these days is used for anything. 90% of the web servers in the web run Linux. Your phone, many Androids, or all the Androids run Linux, so it's used pretty much everywhere. Anyone can contribute to Linux, can foster new evolutions across different hardware, different use cases, different industry, and there's not a single company that can kill it. That's one of the reasons why it's still here and why it's still evolving so much. If you look to projects like Wikipedia, Wikipedia was born in 2001, so that's 24 years ago. They are kind of the same age that Drupal is. There is the possibility of open and constant editing. Anyone can go to Wikipedia, register their user, do changes, have corrections to their changes, correct changes from others. So all this collaborative model that doesn't rely on a single staff or a single funding model. There are several ways to fund Wikipedia. That's one of the reasons that Wikipedia is still there and why it became the standard for knowledge. Usually when you want to know something with a trust version, Wikipedia is always a good candidate. If you look to Git, Git born 20 years ago is the baby on the room compared with the rest of the project we talked about. So 20 years ago, pretty much supports all software development that happens today. Fits perfectly with the open source collaboration. It has a distributed model that anyone can fork and keep history, and that's the reason why it is still here. However, being open, being with a large ecosystem, being with a good ecosystem is not the only thing that is enough to have your project last. If you look to all these three examples, they all had the same properties as well. But if you look to SourceForge, people remember about it? Still a bit? OpenOffice, Second Life, they all were replaced with other things. And why? Well, if you look at SourceForge, they start bundling hardware with downloads with your software, a bit strange governance decision and monetization decision. People started to use other platforms. OpenOffice, there was a lot of fragmentation that slowed innovation. People start using other projects as well. Second Life, it was very hard to have a monetization, and there was a closed governance. So even projects that were kind of simpler and less evolved technically, if you think about Minecraft, surpassed Second Life. So in common, what do we have for the projects that survived? They don't have a single point of failure. So survival is behind a single person or a single leader or a single company. And survival is beyond the hype. So they can go through different economical cycles, but the ecosystem guarantees that it's still there and it's valuable for many people. The ownership of the product across the years also evolved. It's the community that keeps updating as changes are needed. It's the community that are incentivized to perform evolutions of the platform. Moreover, most of these projects, they start to be the infrastructure. That's what you build on top of. You build your products on top of those other products. So they became the infrastructure. They are not really a product. Another thing that is important is that even if they evolve over time, they had solid foundations, so they start with foundations that were there to last. Their governance evolved over time. The decision-making on those projects changed over time. But over time, the trust and the foundations that they had to start with, they were maintained. And that was very important. So let's look to another project that we all know about and that lasts, Drupal. So Drupal was started, or was first released on January 15, 2001 by Dries, and he did it to support a message board project that they had back in the day. So if you subtract the days between today and January 15, 2001, that's 9,000 days ago. It's a long time. If you want to read it better, it's 24 years, 8 months, and 4 days. So it's a long time. So you can see that it lasted. It was never the same, though. Drupal evolved through ages, and I categorize this, made up by me, but I categorize in 3 historical ages. So let's call it prehistory, history, and the current age. So prehistory, which is the time period that lasted from 2001 to 2007, and that has from Drupal 1 to Drupal 4.7. So that's 6 years. It has the foundations of Drupal, if you look to it. So you see hooks appearing since version 1. In 2001, hooks were there. One of the most progresses that Drupal present back in the day, the notion of hooks. The notion of models and themes was there since version 2, so 1 year after, 2002. If you look to nodes and comments that we still use today, they were there since, and blocks and menus since version 4, also in 2002. If you look to maintainers.txt, so this idea that different people have responsibilities in different parts of the subsystems of the code, and this person is responsible for this model, and some other person is responsible for other things, so there's not a single ownership of the whole product. It's there since very early on. You have maintainers.txt since version 4.6 in 2003, and content types, they appeared in 4.7 in 2005. Then came a different time, from Drupal 5 to Drupal 7. That's a long time, 10 years, 2005 to 2015, where you see appearing the first complex subsystems. You have like the database layer, the fields, caching. You start having this notion that there are a lot of things that are better done outside of Drupal than inside of Drupal. So you start having dependencies like jQuery. You start having a big community of contributed models that start leveraging the ecosystem of Drupal and other things that could be glued to Drupal. So things like views, CCK, rules, organic groups, other models that integrate with external dependencies like Varnish, Memcache, Apache Solaire, they all come from this age, the first versions. And back in the day, until Drupal 7, we always had this release policy of it's released whenever it's ready. So there is no fixed date. People cannot expect when things are going to be released. And then we do have the current age, which was basically implemented since Drupal 8. Took a long time to get to this age. It was one of the most frictional moments of Drupal. But in this age, we start having more dependencies. We based ourselves, pretty much all the subsystems in Symfony, in other Symfony components like Twig. We had better subsystems like the multilingual, config management, all that is in core. Drupal is not used anymore for sites. We start having in core things like REST API and web services, and we start having a fixed release cycles. We know that Drupal is going to have a major release on this day or on this month, let's say, and we know that every 6 months we have a minor release that is coming with different features, but the backwards compatibility is maintained for a cycle of 2, 3, 4 years. That really helps, and became way easier to update from Drupal 8, Drupal 9, Drupal 10, Drupal 11, Drupal 12 because of this. Time does a lot of things. One of the things that time does is helping finding the space, and it does it as well with projects. Drupal started in 2001 as a message board, or a software to support a message board. If you look to Drupal, 2010, you had Drupal used in blogs and personal websites. It was very easy for someone without a lot of technical knowledge to do a website and do it with Drupal. 5 years forward, you start having this concept that Drupal was a web Swiss army knife. You can do it, you can use it for everything. You had intranets, extranets, public websites, corporate websites, communities. Everything was built in Drupal. Over time, you start seeing Drupal more specializing on enterprise websites. So it became more complex to work with, and the space that it found was inside the enterprise. And time is something that we can also try to change. Like today, maybe we are in a time machine with Drupal CMS, and we are trying to go back in time and have a different way to impact how marketeers do websites. So it's always a struggle between where time puts us and where we want to be. So the next slides, I'm going to talk to you about a few suggestions that I have for projects and for code and what you can do when you are working on code. To make sure that your project can last. So, 6 categories. How do you measure the time, what you put on your foundations of your projects, tests and documentations, and how you address changes, and how you address refactoring or in release. Okay? So first thing is, how do you measure the time? So usually, when we think about the project we are working on, we think about the short run. We need to think about the long run. Usually, we think about the 3 months that we spent building our project. Okay, let's put it like an average time that we spend doing a project. But in reality, what we are doing is something that is going to last for 5 years, or what we want to do is something that lasts for 5 years. So don't think about the 3 months that you are spending building it. Think about the next 5 years that you're going to spend using it, refactoring, and updating it. That really helps, which is basically a change of mindset from project mindset to product mindset. If you are responsible to maintain your product, then you're going to think way ahead or how you're going to build things so then they last for 5 years. Second aspect is the foundations. So this is important. Of course, the project is going to change over time, and many things will change, but foundations are important. Start with your scope. Usually, smaller, the better. You can always iterate after, but if you maintain your scope very well controlled, because it will change tomorrow, and you start with a small core for your project or for your product, and you prepare for expansion in the future, that's always easier. Data, when you start building your project, is the hardest thing to change. You can change your architecture, you can change your code, you can change your services. Your data, if you don't model it correctly, is going to be very hard to change because you don't have that data to come back in time. So spend as much time as you need to model it correctly, make sure that you capture the data points that you want, and be aware that somewhere in time there's going to be a need for a migration. And your data is always going to be the biggest weight that you have on your project to change in the future. Users are as important as code. The earlier you expose your project to users, and the earlier you start building your ecosystem, the best it will be for your product. The ecosystem, in the end, is what you want that will own your product. So early exposition is super important. And in terms of architecture, that's the that's the thing that can change the most. But make sure that you start your application with this idea of subsystems, loosely coupled. Make sure that you balance what you build versus what you depend on your dependencies. And have this in mind that usually the external dependencies that you don't control, they are the first ones to die. They die first, then your code. So be prepared for that. And evaluate if you really need a dependency before introducing it in your project. Testing, it's one of the main factors that can expand your project lifetime. If anytime that you need to change anything in your code, you don't have any guarantee that it's going to keep working, you're not going to touch it, or you're going to be very lazy about the way that you touch it. So the only way that you guarantee that it's keep working is not by human testing or user testing or final user testing, but really retesting it again. Automatic tests, which are rare to be written, but because they are expensive to write as well. They take time to run, they take time to write, they take time to maintain, but they guarantee longer lifespans. Ultimately, software without tests is always more expensive and always more prone to die in the long run. That's something that has tests included. And they should run frequently. It doesn't matter if you do have a test suite that ran a year ago against a dependency that was updated or against a system that doesn't exist anymore. If you don't run your tests frequently, either night or monthly or daily or whenever there is a release, with frequent releases, then the tests are just void. They don't serve for anything. They were there, they were built, they were invoiced to the client or to your product team, but they are not useful. Documentation is also important. So usually when you look to a code that you wrote 6 months ago, that you worked 2 years ago, typically are the 3 things that you want to know. How is it done in this code? I'm looking to this feature, I need to change it. How do I do it? When was it done? Is this still needed? So a few suggestions. You'll not be the same when you get back to that code that you wrote 6 months ago. Maybe you will never get back to that code. Some other colleague will. So documentation and code should be as close as possible. And sometimes it's more important to give hints on your code about the history of that code than really what the code is doing. It's easier to say, well, I do have a commit policy, a commit message policy that traces back that commit back to the ticket where that was done, or back to the merge request where that was done, or have public discussions over merge requests that can help on finding why that was done. That usually that's not in the code, it's somewhere else, but it's super important to trace back the two. Second, there's changes. The way that you address changes really matters how your project is going to last. Time passes, the requests for change arrive. There's always a need to do a reality check whenever there's a change needed in your project. Is this change really needed? Is there any other way that I can do it with what I already have, the feature that is being asked? Is there any way that this feature is going to replace or deprecate another feature that I have on my project? If yes, then it's always a good opportunity to refactor. And it is always a very hard balance between someone asks you to do a change on your project or on your code, and you are lazy, you just do it, the minimal scope that you can affect. You be bold and you say, okay, this is a good time to change other things as well because other things will be affected. You go out of scope, you start to refactor the whole thing because that's a good opportunity to do it, and you get fired when you do that. So it's always a very hard balance to maintain from scale 1 to scale 4. So always try to stay in the middle. Release it's whenever you introduce changes for your project or your code. So you did something, and now you're going to package it and release it. Anytime that you do release, anytime that you package a few changes together, make sure that you use that opportunity to be close to your upstream as possible, to be close as your dependencies upstream as possible. Couple of other suggestions: couple your release cycle with your major dependencies. Drupal does this very well. We know that when the Symfony version for these components is going to die, so we try to couple our releases with it. We prepare for maturity. We have releases that go from alpha, beta, stable, and we gave expectations about the dates that these releases are going to happen. So this was the suggestions about code and projects. So second part, as I told you, was about ourselves. Sunday will not be here. That was an amazing slide that they put. So they have the exact room that I was going to talk. That's uncommon. But Sunday will not be here. Time will pass by you, and you need to be prepared for Sunday. You need to be prepared for the day that you are not on the project anymore. You need to be prepared for the project to be able to run when you are not there. Successful projects have a larger user base. They have more people that are able to put more effort or put less effort as life goes by, or our job goes by, as people move jobs inside companies. The more the spread the knowledge is, the easier it is for someone to jump in, the easier it is going to be that more people are going to work with it. And you are going to be replaceable. The more replaceable you are, the better. Time also finds us. Time also helps us finding our space, not only products. So we start with juniors. We don't have a legacy to carry. We have a learning mindset. We are not responsible for anything. We can play with all the hottest technologies. We go to boot camps, we go to universities that tell us, learn what is hot, learn what is latest and greatest. That's going to give you more jobs. We don't learn what is battle tested. We don't learn PHP because that's old and whatnot. When we are seniors, we are deep investment on older stacks. We know that our expertise came from there. We have less time to experiment. We start being busy with leading teams, reviewing code, fixing production issues. And we also get comfortable. Like, what is new is less comfortable for someone that is a bit older. And expertise is valuable. Usually it's better paid as well. So there's way less opportunities to be exposed to to new tech that is shiny but less mature. It's always hard to give a suggestion on this point, especially if we stay on the code. But it's true is that it's easier to ride waves early on. So when a wave comes up, it's easier to catch it than it is for a junior right now to catch a wave of Drupal, for instance. But the reality is that engineers create legacy when they adapt something that they learned in the past somewhere else, some other technologies, some other frameworks, to the new wave. The real challenge for an engineer is not to catch every wave. It's impossible to do that. It's very easy to catch a lot of wrong waves. But whenever you catch a wave, then try to apply what you learned from the past, your principles, over the tools. Try to think about what you know about systems and not really about the reality. Two things that I think is important: keep learning and unlearning. You need to keep learning on new things over practice, not over theory, not over tutorials, but over practice. And something that is very important, and it's hard to do when you go through our career, is this thinking that fast you go alone, together we can go way far. So it's always important to have a team with you that can teach you more and can expose you to new things. So, two final questions. Did Drupal pass the test of time? Well, 9,000 days, 24 years, possibly very true. Why did it did it? Well, there's a few categories that we saw in the few slides before that made it pass the test of time. We made core more resilient. We experienced first outside with experimental models, then we brought it in core in a more mature state that really helped mature the quality of the Drupal as a product. We enforced the trust. We extended what we request in terms of automatic testing. We grew the standards. We didn't have the same standards all the time, but we grew the standards over time that maintained trust. We started having expected dates for changes, and we expected changes whenever those dates were set. That was super important to improve trust. We preferred always together instead of fast. We adopted and influenced external dependencies like Symfony. There's a lot of things that we influenced. We dropped what was not needed anymore, and this is something that we still need to work a lot. And we always try to enlarge the project maintainers and contributors. We replaced key members. We empowered many careers out there, people that start with Drupal and now they are working on whatever, but Drupal was super important for them to start, and to start either in development or web development. So with all of that, I think the answer needs to be positive dev. Of course, we passed the test of time. And the final question, what about the future? So I asked ChatGPT this one. Can you tell me what the website in the future will look like? And what it came back with, was the website of the future might not even look like a site. It will be an adaptive, AI-driven, immersive layer of reality that lasts because it bends with human needs, which is an amazing theory. But the reality is that there's lots of questions, and every year we have more questions. And in this age of AI, those questions are even changing faster in terms of their answers. Will there be websites in the future? How are people going to interact with them? What it will take to create something for the web? And when is our web legacy dying? What we have done is going to die. So, I don't know. I think no one will know. But my final suggestions would be stick to the basics. So keep it simple, but design for change. Try from early on, whatever you are building inside, outside companies, a product, a project, a dependency, try to build a community, not just the product. Prioritize the way that you can interact with other tools and prioritize standards. They always help keeping up. If you build something that is standard, even if it dies on the future, your technology, you can always migrate easily. It was standard anyway. Evolve governance as you scale, and focus on principles, not trends. And the final one, and I think that everyone knows that, it's we need to adapt all the time. There's always new things coming. So I have a confession to make. This was actually my first presentation that I have done, where every slide actually starts with a prompt with ChatGPT. And that's a change on the way that we start building something and we start developing one thought for a slide, for instance. So that was my talk. I want to thank you for everyone organizing the DrupalCamp and everyone sponsoring DrupalCamps. And I hope I didn't waste your time. And I open for questions. I think we still have some time. Yeah. So there is a Telegram group for the ones that are not aware, which is called DrupalCamp ES Space 2025. So there's already a lot of people there, 200 people. So you probably can find somewhere around if you don't find the right channel name.
Well, I would like to talk a little bit about my current project because when you were talking in the point in the presentation about the foundation, you say that we need to talk with the client to say then that we would have to build the core of the project, and later we will be evolving the project. That was very difficult in the current project because they had a Drupal 7 site, and they might say, we would like to have the same as in Drupal 7, and we have the new site, we would like to have the new site in DrupalCamp. Just a refactoring, but with the new technologies. And it was very, very difficult to make them think, just build the core, the base of the futures, and we will evolve later. That is very difficult for a medium-sized or big-sized project. So it is not something that we can control sometimes.
Yeah, and it's harder to do when you need to do such a large migration, such as Drupal 7 to Drupal 8, which is a rebuild. There's a lot of effort going there. If you had the same problem between 8, 9, 10, it would be a lower barrier to enter because the expectations would be lower. It's even more frustrating. I don't know if you have any experience to work on personal projects that you are responsible for the product and the code. And you spend a lot of time building something new, and you expect your users that they'll love it, and no one did, and they want the old look, and they want the old thing, and you know that it's going to take 1-2 years for them to adapt. And it's just a question of habit. It's just a question of don't break those habits suddenly because people will stop using it. And we kind of felt the same as well with the majority of experience that we had in Drupal 7. People were used to do things in some way. Lose a lot of people just because of habit, because they were not wanting to learn new things. They just want to keep using what was there before, and that's always a challenge. So, but the less you break those habits, the more evolved you are. Always the easiest to evolve.
Futures, we have that problem. We say this is the modern way in how it works now. No. But we would like to have like in Drupal 7. But this is the future. This is like the website works now. No.
It's very common, yes. Thank you.
As developers, we have to build the product, build new features, fix bugs, and do some polishing and refactoring. And what's your recommendation of split time as developer to these two activities? Because how much time to put to polishing and
I think it's always important, depends on how you organize your team and how you organize your budget, but it's always important to keep a buffer of, I don't know, 20, 30% to technical debt, refactoring. It can be addressed in different ways over the duration of the project. It can be glued with whenever you are selling a new feature, saying, okay, this is going to impact this and that, so let's try to refactor that subsystem as well. But if you work on a budget for a year, for instance, it's always important to say, let's keep it 20% for technical debt, for updates, for making sure that you are closer to the upstream. If you don't do that, then sooner or later it's going to be very hard to change anything on that product. If you keep, let's say Drupal, if you keep a Drupal site with Drupal 8 or 9 and you built it on something that was experimental back in the day, then it starts being very hard if you didn't update in the last years to go to the edge. And you end up spending the money that you saved on not spending on technical debt, you end up spending when you have to rebuild it, if you still have that opportunity to rebuild it. My opinion.
I think it depends much on the context, on the project, the people involved, but it can vary a lot. Why do I feel sometimes like the one turning off the lights is needed?
I could hear.
Is it really needed?
I don't think so.
Thank you very much.
Okay.
So why do I feel like sometimes me or some of us developers feel like the ones turning off the lights in the middle of a party? I mean, if you are focusing on putting reasonable effort on the future, on the long term, in the people working around you, there could be some chains, some elements of the chain that they are short focus driven because maybe lack of experience, maybe intent. So in order to one accomplish that that cautious approach on long term, you have to deal sometimes with a social
Yep.
issue there where some people around, maybe the majority, maybe not, they are kind of, it has a penalty because they don't want, or they can't see that. So what would be your advice for us developers when many elements of this chain, which have a role in decision making also,
Mhm.
how to communicate the best, the better, and to justify that effort, but sometimes only pays out, of course, pays out in the long term.
So I think there's two aspects of it. First is, I know. So I think there's two aspects. I think that there's the aspect of how do we involve more people that are juniors and don't want to work on legacy. Or there's different ways. I wouldn't put it as penalties, but more as incentives, like what they can learn. How important is that going to work? How important is that work going to be? Like, it's okay to try and experiment with new technologies, but in reality, if your impact is not being felt on real world, then that's just void. So that's a way to really incentivize juniors to say, you are going to work on something that is important. Like from early on, be able to give them the possibility to break things that really matter, even if that has consequences. That gives them the ownership of the thing. They start thinking that they own it as well, not just I'm hearing, just passing by until I find something that I can do from scratch. About business, it's always about thinking about the consequence on the long run. If you are maintaining an application that is responsible for personal data, financial data, and you are not thinking about what could happen in the future if we are just running on an old thing that no one understands and no one maintains, that's going to cost you in the future. And the same thing, even if it's easy to think of something that is just stable, that's been there forever, never touched it since 1994. The reality is that the moment that we want to move away from that technology, from that product, the more knowledge we have about it, it's always the easiest. So have people involved in the project that is able to change it often, it's super important. Not carry something that is just there as a cow to be milked by the company, that when the day that some change will be needed, really, no one will be able to change the cow for another animal. Just to do that. An image. More questions? I think we're also out of time, so thank you.